Rebecca travels by car from Bunbury to Perth every morning. The time it takes her to do the trip is normally distributed with a mean of 130 minutes and a standard deviation of 4.5 minutes. If she leaves Bunbury at 7 each morning, what's the probability she arrives in Perth before 9? So that's 2 hours or 120 minutes. So what we're after is here. So if we're thinking about a normal distribution, 130 and 4.5 squared, we're just looking at the probability that x is less than 120. So that's just going to be, I think we might clear some space here. So interactive, distribution, continuous, normal CDF. So less than 120, so 120 is the upper. The lower would be negative infinity, and the upper would be 120. And the sigma here we know is 4.5, and the mu is 130. So that gives me 0.0131. And the probability she arrives in Perth between 9 and 9:15. So the 9 is 120 minutes. So that's 120. And 9:15 would be 15 minutes further on. So that would be 135. So all I need to do is change that negative infinity to 120 and change the 120 to 135. 0.8536. Looks like a 6. 0.8536. For 1% of the time, she arrives in Perth too late to find a parking space in her favourite place. How long is the trip from Bunbury to Perth taking her on those occasions? So, if we look at the distribution, so what we're wanting is for this to be 0.01, or alternatively this to be 0.99. So we're wanting the value just here, and we know that the mean is 135. No, the mean is 130, and the standard deviation is 4.5. So that's going to be an inverse normal, and we know the probability. So if we use a left setting, so that would be the 0.99 then, and we know that the sigma is 4.5 and mean is 130. That's 140.46, so it's 140.468.5 and so on. We want this to the nearest minute, so that is 140 minutes on those occasions. Now this last part of this question is actually quite a tricky one, and I really suggest that you pay attention to this because it does come up in exams. And so what we have is Rebecca also catches the train. The times taken for the train trip from Bunbury to Perth are normally distributed. Now what we're actually then told, we're not told the mean and the standard deviation. That's what we've got to find. We're told that if this is 120, 5% of the trips are down here. 12% take more than 145. So this is 0.12. Now the way to do this type of question is in a sort of Z-score sort of way. So what we're going to do is go to inverse CDF and leave this as 1 and 0 and put a left tail setting to 0.05 and click OK, and we get negative 1.6. Let's call that negative 1.645. So negative 1.645 is equal to, now remember this is the mean and we've got a standard deviation of sigma, so if we z-score this 120, we get 120 take away mu divided by sigma. Do the same at the other end. So we'll go for an inverse distribution, inverse normal CDF. This time I'm going to go for a right setting with 0.12, and that gives me 1.1750. So, well, let's use the same number of decimal places. So 1.175. And that is going to be equal to, in this case, 145 take away mu over sigma, because we're z-scoring that. And that's simultaneous equations. And of course, we can use the simultaneous equation solver on the calculator to solve them. So, what do we have? Negative 1.645 is equal to 120 take away, and I'll call mu x just for simplicity, and we'll call sigma y, and then I've got 1.175 equals 145 take away x divided by y, and we need to tell it we're solving for x and y. And so that gives me that mu is equal to 134, let's call it 134.6, and the standard deviation is 8.87.